Welcome friends. நம்ம என்ன பார்த்துட்டு இருக்கோம் CSIR problems CSIR-NET problems பார்த்துட்டு இருக்கோம். Real analysisல sequences and series based பண்ண problems. Okay. So we have been doing problems on sequences series of real analysis, real sequences and real series. Now we are given a question. If xn is a convergent sequence in R and yn is a bounded sequence in R, then we can conclude that A. xn plus yn is convergent. B. xn plus yn is bounded. C. xn plus yn has no convergent subsequence. D. xn plus yn has no bounded subsequence. So which option is correct that we have to choose? Now to start with, we are given that xn is a convergent sequence. So now we have to address the option A. To address the option A, what do we do is, of course, you prove that something, some result is false. It is enough if you produce a counter example. If you want to prove that some result is false, it is enough if you produce a counter example. So we are going to prove that this is false. So you take xn to be 1 by n, which is a convergent sequence, and yn to be minus 1 by n, which is an oscillating sequence, which is not convergent. Okay, now you add these two, xn plus yn. So it is going to be 1 over n plus minus 1 power n. As you give values for n, you will have a sequence of this type. For large values of n, we see that this tends to 0, whereas this oscillates between minus 1 and plus 1. Therefore, this sequence is not convergent. So we conclude that xn plus yn is not a convergent sequence. When xn is convergent, yn is bounded. Therefore, option A is false. Option A is false. Now we address the option B. xn plus yn is bounded. Xn is convergent. So write down the definition of convergent sequence. So for every given epsilon greater than 0, there exists an n naught in n such that mod xn minus l is less than epsilon. Because we are in real numbers, so metric is modulus. Okay. So now when you write down the definition of modulus, you will get this. This is true for all n greater than or equal to n naught. For all n greater than or equal to n naught. So before n naught, there will be finite n minus 1 terms will be there. You pick the maximum of that, and you subtract that maximum from here and add that maximum here. So for then in that case, what will happen? Xn lies between these two. Xn lies between these two for all n. Xn lies between these two for all n. Therefore, xn turns out to be bounded. Therefore, xn turns out to be bounded. Okay. So given that in the case of B, given that yn is bounded, given that yn is bounded, then by the definition of boundedness, yn is less than or equal to some capital M for every n in n. Now consider the sequence xn plus yn. So now consider this. This is what we have to show. Now modulus of xn plus yn is less than or equal to mod xn triangle inequality mod yn. If you are prepared to write this as L plus epsilon plus A and yn as plus m less than or equal to m, then we see that this is a bounded sequence. This is true for all n in n. So implies xn plus yn is a bounded sequence. It's a bounded sequence. So option option B is true. Option B is true. Now, what about the option C and D? What about the options C and D? Now, what you do here is look at the option xn plus yn has no convergent subsequence. So option C is false. Option C is false because every bounded sequence has a convergent subsequence. Bolzano-Weierstrass's theorem for sequences. So what is Bolzano-Weierstrass's theorem? Bolzano-Weierstrass theorem. Weierstrass theorem says every bounded sequence has a convergent subsequence in a metric space. This is true in a metric space. Okay, so every bounded sequence has a convergent subsequence. Now xn plus yn being bounded, it should have a convergent subsequence. Therefore, but we are given that it has no convergent subsequence. Therefore, this is false. So option C is false. So it has no convergence. But again, option D is also false because we are given that xn plus yn has no bounded subsequence. That is also false because every bounded sequence has a convergent subsequence. And just now we proved that every convergent sequence is bounded. So if this sequence is bounded, then it should have a convergent subsequence. And by B we proved that it is bounded. Therefore, xn plus yn should have a bounded subsequence, but we are given that it has no bounded subsequence, which is wrong. So only option B is the correct option. Okay.